Hi, this is Mike Butler from Process Engineer School. Today we're talking about process control stop conditions and how to determine if your flow rate is too far from set point. So first we're going to go through an example process. We're going to go through a process flow diagram. Next is we're going to go through the desired outcome in terms of what the product that you're trying to make is and what happens if you do it wrong. And lastly, we'll spend most of the time going through typical stop conditions. The process that we're working on today consists of a storage tank going through a PD pump, positive displacement pump. We measure that flow going through a flow meter, and it goes through an on-off slash open or close valve that is just before it is injected into a main header, or it could be going into another tank or whatever your situation is. The flow meter transmits the signal back to the PLC, which sends information to the PD pump, whether it needs to speed up or slow down in order to get to that set point, the target amount of flow rate. The desired outcome is that we're making the actual formula that we want to make, and that comes from the desired set of consumer needs. Too much or too little of any one material result in off-quality product. So this is all pretty obvious. Some really bad situations could happen here, such as too much enzymes is a health risk for consumers. Enzymes are an active ingredient in many consumer products. Too much of them, and a person can get sensitized to that material. Too little, another example is too little preservative, and finished product can grow microbiological growth. So preservative is is a common ingredient in consumers' products, and if you have to have enough, otherwise if there's too little, then they can grow micro growth in the finished product, which will result in either an off odor, or the color can fade, or if the product is supposed to be white, it'll turn brown, and if it's a different color, it'll basically just turn brown. And ethanol is a common ingredient, or there's other explosive chemicals that are used in consumer products, and if you add too much of it, that is clearly going to be a risk for explosion. So here is the way that we need to control our flow rate. Some typical stop conditions are looking at the deviation of the flow rate from the set point. So if you're deviating for a certain percentage for a certain amount of time, then you need to stop the process. So the common stop conditions that I've seen are a high deviation for a short time and a short deviation for a long time. Examples that I've seen as common are plus or minus 30% deviation for 5 seconds and plus or minus 5% for 30 seconds. And the way that most PLC logic is written is that there has to be some sort of delay. Otherwise, you're going to have a deviation right off the bat when you need to allow some amount of startup time for your process to line out. And that delay is commonly 10 seconds. So looking at the purple signal here, I looked up a signal on the internet, and I wanted it to represent a flow rate in our case. So the step line is the set point, and the purple is the flow rate is the actual flow rate we're trying to control to the set point. So you have about a 10-second delay when we're not really comparing the flow rate versus set point. But after that 10 seconds, we start comparing that deviation. And when that deviation goes beyond 30% of the set point, then we start that timer. So if that timer goes beyond 5 seconds, then the process needs to shut down. And the same is true for the low deviation for a long time. So the plus or minus 5% for 30 seconds is calculated the same way. You have a 10-second delay when we're not doing the comparison. But as soon as that flow rate deviates more than 5% from the set point, we start the timer. If that timer goes beyond 30 seconds, then the process needs to stop. So that is extremely simple. There are situations that you can run into that need to be a little more complicated. For example, how many times can you have this process stop and restart in a row before we have off quality product. For example, if you have a flow rate that is slow to get to set point, and that happens once or twice, it's probably not a problem. But if every time this process starts, we are making off-spec product for either less than 5 or 30 seconds, depending on which stop condition was met. But if you do that repeatedly, then eventually the amount of each raw material in the tank or wherever this is going to be off-spec. Another condition that you could add is that if you have 3 restarts in a row, then you actually have to stop and drain the tank. There are more fancy ways of calculating that, such as using concentration calculations, where continuously you're looking at how much of the raw material is being added and how much of the raw material is being taken away in the form of finished product. So if you were to have a flow meter at the exit of the tank that you're feeding, you know how much finished product is leaving, you know what percentage of the finished product is a particular raw material, and so you can do a mass balance that looks at how much raw material is coming in and how much raw material is coming out, and from that you can calculate the concentration, and probably from some formula cards you know what the concentration is supposed to be, and if it goes outside your limits, then you can force the process to stop and drain the tank. So that's really it. Today we've gone through our example process where we're working with a positive displacement pump on a VFD. We talked about that it's very important that we're making the correct formula. We're avoiding unsafe combinations of raw materials. And we spent most of the time going through our typical stop conditions, a plus or minus 30% for 5 seconds and a plus or minus 5% for 30 seconds. I think I said that backwards. We talked about having a plus or minus 30% for 5 seconds and a plus or minus 5% for 30 seconds. And those are the 80%. Those are the 80 for the 20 in terms of most important to implement. There are some other conditions that you could have that would make sure that repeated situations where you're having stops and restarts don't allow the finished product that we're making to go out of spec. So if you're still there, if you've heard all of this, I would love to see some comments below about what you're interested in learning more about, and I can make videos of it or we can talk about it offline. And also please subscribe to this channel if this is what you find interesting. Okay, again, Mike Butler from Process Engineer School. Thanks for tuning in. Thanks. Bye.